So first thing that you need to realize whenever you are trying to working out such kind of question, first you must have the binomial expansion on the same. Yeah, find the expansion, and then once you have the expansion, you can be able to simplify the coefficients. For you to do part B, which is asking to state the approximation of this, first you take those and equate so that we can be able to get the value of x as shown here. Once we have the value of x, we can be able to put into this expansion that we had gotten so that we can get our answer down here. So this is one of the question that is highly can probably be asked. As far as binomial expansion is concerned, you can also be expected to work out derivative. So if they are going to ask you a question where you are finding a gradient of a function, maybe you have done the expansion up to this level and they tell you now if the expansion was function f of x, find the gradient of the function at the point x is equals to 0. You are going to take this function, differentiate it, and then substitute the value of x. As I also mentioned in the previous question that if they test the question to do it sequence and series. For instance, we are told here an arithmetic series S is given by 2, 5, 8, 11. We can identify that the first term, basically here the first term is 2. So if we are finding the number of terms in this series, this is going to be our last term. And this is our first term. So which means that if you find the value of n for term 254, you are going to get the number of terms in this particular series. So that's why I said nth term is a plus n minus 1 into d. So which will mean that if you work it out, you are going to get it as 85 terms. And for you to find the sum of the series, you are going to use of this formula that we have here. Nth term is that sum of n terms is given by n Sn equals to n over 2 into 2a n minus 1 into d, or you can be using this formula sum of n terms is n over 2 into first term plus the last term, and that is also going to give you the answer. If you do that, you're going to get 10,880. So basically that's what you are going to do in that particular part. Guys, if you are new to Proflan, consider subscribing so that anytime I'm going to do more tutorials, even for P3, as you're going to do P3 May, June next year or January, I'll be able to do more tutorials on that. So if you're new, consider subscribing so that anytime I'm going to do that, you'll be notified. We need to go down and get to see in this exam of January 2025 which other question, which other topic showed up in that exam. So let's look at question number 3. Yeah, question number 3, you can see here we have a cuboid, and when you see a cuboid like this, something that speaks up to us is that we are going to talk about differentiation, and we are going to try to see how the question was asked here. The figure shows an open topped container holding water. It's open, so which means whenever we are going to work out, we are not going to make use of this top. This top is not there. So if you are finding the surface area, you are not going to include this top. That's what that question, that part is saying. Then the base of the container is a rectangle that measures 3x by x. So meaning we can be able to find the area of the base. And the height is y. Given the capacity is 120, so the volume is going to be 120. So that is key. That is important. Show that the area of the sheet metal used to make this container is basically area equals to p x squared plus q over x, where p are positive constants to be found. So once we do that, use calculus to find the value of x for which a stationary value, and then we are supposed to find d squared a dx squared, and then to show the value of x found, this gives the minimum value of a. So the first thing that we are going to do in part A, since we are supposed to show that the area is that, the first thing we are going to do is to find the volume. Volume of a cuboid is length times width times height. And the length of this cuboid, we were told it's 3x by x, and the height is by y. So which means that 3x squared y is equally 120. So which means that we can be able to find our volume there. And if you work it out here, you shall have your, because we need to go back to the surface area, it's in terms of x, so we should make y the subject of the formula here. Our y is going to be equal to 120 over 3x squared. And if we work it out, we are going to get 440 over x squared as the value of y. Next, now for us to find the surface area, we are going to say the surface area is going to be 3x times x, that is the area of the base, plus 3x times y. Basically that is the area of this side times y, because this is y, the area of this side here. So which means with that we can multiply by 2 because there is the area on the other side, times 2 again, plus now x times y times 2 because there are two sides. So we shall say area is equals to 3x squared plus 6xy plus 2xy. But we need to remember that our x is basically 40 over x squared, so we are going to say therefore our area is going to be 3x squared plus 6x times 40 over x squared plus 2x times 40 over x squared, so that we can simplify this to 3x squared plus 240 over x plus 80 over x because of that. So we can be able to simplify that now. Yeah, so meaning that we can say this is a equals to 3x squared plus LCM is x basically here, x, and then we can say 240 plus 80 is going to be equals to 320. $320 over x So basically that's what we were supposed to show in this particular question. Yeah, that is part A. And then we are told that using calculus to find the value for x for which has a stationary value. So in order to use calculus there for part B, we are going to appreciate that area is given by the expression 3x squared plus 320x negative 1. Then we can be able to do dA dx, and that's going to be 2 will come down, we shall have 6x, and we decrease the power by 1 here, and this will be becoming negative 320 x raised to power negative 2. But we know that at the stationary point dA dx is going to be 0, so we shall have 6x minus 320 over x squared. I just want to bring the power down, then I can be able to say this is equal to 0. I multiply all through by x squared, so we shall have 6x cubed minus 320 is equals to 0. What do we do at that given point? We shall take that on the other side, so that we can have 6x cubed is equals to 320, and divide by 6, which will mean that if you work it out, you'll have x cubed is equals to 320 divided by 6, which translates to 160 over 3. So in order to find our value of x, we shall find cube root. We do the cube root there, so which means that our x is going to be cube root of 160 divided by 3, and if you work it out, you get your answer, which is approximately 3.76 as the value of x, as the value of x for that. Then you are told find d squared a and dx squared, hence, and show that the value of x found in part B gives the minimum value. So what do you think we are going to do there? We are going to differentiate that function that we were having there again, so that if we are working it out, d squared a over d x squared is going to be basically differentiating that function that we have. If we differentiate this again, we are going to get 6. If we differentiate this power is going to go down, so we shall have plus 2 times 320. Now that becomes 640 x raised to power negative 3. Then for us to check whether it's a minimum or maximum point, we shall now say d squared a over dx squared, and we are going to evaluate at x is equals to 3.76. So anywhere you have x in this expression, we are going to substitute 376. Yeah, so that's going to be 6 plus 640 into 3.76 raised to power negative 3. Let's check the answer it will gonna give us. 6 plus 640 into bracket 3.76 raised power -3. That gives us a value that is 18. So we are having 18 here, and when you have 18 like that, we can say d squared a over dx squared is actually greater than 0. If it's greater than 0, so this is a minimum point. Minimum area. Yeah, because the question was asking us to do what? The question was asking us to show that the value of x found gives the minimum value of a. That is it. Let's check also B. Use calculator to find the value of x for which a has stationary value, giving your answer to 3 significant figures. Yeah, so sometimes you'll find a question whereby I tell you to find the value of that area. Use calculus to find the value of x for which a has a stationary value, giving your answer through 3 significant figures. So basically that's what we are supposed to do there. Yeah. So minimum value of what? Of a. So since d squared a dx squared is greater than 0, so this is minimum. So if we could have gotten a negative number, we could have said it's a negative is a maximum. If you have a negative, you will say that is maximum. Question 4 is an area we are told to work out the sum to infinity, given that the particular geometric series, the sum to the first 3 terms is 70.2, sum to infinity is 75. We are supposed to find the common ratio and find the first term. How do you go about a question like this? Whenever you see a question that looks like this, you need to remember these formulas. That a sum, okay, let's start. Sum to infinity is usually given by, sum to infinity is given by which formula? Sum to infinity is usually given as a 1 minus r, and for that to happen, r should be less than what? Less than 1, that condition. And for geometric series, we know that nth term is going to be a to r n minus what? R n minus 1. And sum of n terms is either a into r n minus 1 or r minus 1. The other formula is sum of n terms is a into 1 minus r raised to power n, or 1 minus r. So those are the formulas that we learned in this topic for geometric progression and series. But in this case, since we are talking of the sum to infinity, is that sum of the first 3 terms, we can say it's sum of n is, because it has sum to infinity, we shall say into 1 minus r raised to power n. And this is going to be 1 minus r, like that. So we can say, therefore, that a into 1 minus r raised to power n over 1 minus r is going to be equals to 70.2. That's one of the equations that we're going to use. The second equation that we're going to use is the equation to sum of infinity. And to do that, we are going to say it is going to be sum to infinity is well seated here. Sum to infinity is well seated here. So we are going to say a over 1 minus r is equals to 75. So which means that from this particular point we can say that 1 minus r is basically equals to let me just say our a is going to be equals to 75 into 1 minus r. So what are we going to do with this? We can be able to, anywhere we have a, we can be able to substitute this guy there. And that is exactly what I'm going to do here. I'm going to say 75 into 1 minus r into 1 minus r raised to power n divide by what? Divide by 1 minus r is equals to 70.2. So you can see this part and this part will cancel out. We shall have 1 minus 1 minus r raised to power n is going to be equal to basically equals to 70.2 over 75. Yeah, I think we are in the right track. First, let us try to simplify 70.2 divided by 75. What does it become? Becomes 1 minus r raised to power n is equals to 117 over 125. So something I want you to remember is that we were talking about the first three terms. So n in this case is going to be equals to 3. So which means that we shall have 1 minus r raised to power 3 is equals to 117 over 125. We can take r on the other side, and then we shall have 1 minus 117 over 125 is equals to r cubed. So 1 minus that is going to give us 8 over 125 is equals to r cubed. And then at this given point we need to find cube root, and we find cube root here, so which means that our r is going to translate to if we find the cube root to that, we are going to get 2 over 5. So our r is actually 0.4 as shown here. And then which means that in order to work out the value, because that first part we were supposed to find a common ratio a, and the b we are supposed to find the first term, and already we had said the first term is going to be that. So how will we find the first term? our first term is going to be this value that we have here, then we substitute the value of r that we have obtained. So I'm going to copy that and then cut that. So I'll go down here and I say this is this is where I'll just paste it here. That is expression, so that I can be able to say now this expression that I have here, I can be able to use it comfortably without any reservation. Say this is part B. We have gotten our common ratio to be 0.4, so it will be 75 into 1 minus 0.4, and if we work it out, 1 minus 0.4 then times 75, our value of A becomes 45 degrees. 45, not degrees, it's 45. So basically that's what you are supposed to do when you are working out question to do with geometric series. And in this case we have learned how to use sum to infinity and also sum of terms in a geometric sequence. Going down so that we can also see question 5, what we are supposed to do. And if you are new to Proflan, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. We shall be having physics also coming up, so that you can be able to learn. Share this live, like, and also subscribe if you haven't. If there's any question coming in, you can as well ask questions, so that we can be able to respond to you. We are told that f of x equals to 3x cubed plus ax squared minus 10x plus b, where a and b are constant. Given that 3x minus 4 is a factor, show that 16a plus 9b equals to 56. So in order to show this, what we need to do is to take this factor we are told here we equate to 0. So for part A, we are going to take that factor 3x minus 4 and we shall equate to 0, so that we can be able to find the value of x, and the value of x in this case is basically going to be 4 over 3. Now we are going to find f of 4 over 3, and that f of 4 over 3 should be equal to 0 because this is a factor. But something that we need to remember is that f of x was given as 3x cubed. So we are going to say 3x, our x is 4 over 3 cubed plus a into 4 over 3 squared minus 10 into 4 over 3 plus b, and that should give us a 0. Now we need to simplify whatever we're having here, because 4 over 3 cubed is going to be what? (64 over 27), and say this is going to be 3 times 64 over 27 plus a times 16 over 9 minus, if we multiply this, going to be 40 over 3 plus b is equals to 0. 64 over 27 times 3 is going to be 64 over 9, and this is going to be plus 16a over 9 minus 40 over 3 plus b is equals to 0. So up to that point, you see you can multiply all through by 9, multiplying all through by 9, all terms by 9, we shall have 64 plus 16a minus, this is going to be 120 plus 9b is equals to 0. But if we take 64 minus 120, that's going to translate to negative 56, so we shall have 16a plus 9b is equals to 56. What does that mean? If we have gotten this, let's check what we were supposed to show. Basically, that's exactly what we were supposed to show at that given point. Find the value of a and the value of b. Which other information is given? It's given further that when f of x is divided by x minus 2, the remainder is b. So which means that we are going to also say x minus 2, we equate it to 0. X minus 2, this part b, we equate it to 0, then it means that x is equals to 2. And then I'm going to substitute, anywhere I have x, I'm going to substitute 2 in the original function so that I can equate that to b. So we can be able to say f of 2 is basically equal to the remainder is b. So that's what we are going again to substitute. So when I substitute, I'm going to say 3 into 2 cubed because the function was 3x cubed. So anywhere I have x, I'm going to put 2, then plus a into 2 squared minus 10 into 2 plus b. The answer should be equals to b. Now this is going to be 8 times 3, which is 24, plus 4a minus 20 plus b is equals to b. So at this point you can see that this b and this b will cancel out, and then we shall have 4a plus 4 is going to be equals to 0, which means a is going to be equals to -1. Now for us to find the value of b, we are going to substitute the value of a that we have gotten into the equation that we had formed here. So we are going to find the value of b there. So we shall say this is 16 into -1 plus 9b is equals to 56, which means that 9b is equals to 56 plus 16. Divide by 9, divide by 9. Our b is going to be equals to this is going to be 72 over 9, and our b is going to be 8. 8 is going to be our value of b. The next part of question number 5, CS factorize fully. Factorize fully. So now that we have the constants, we can say part C, f of x is basically equals to 3x cubed minus x squared minus 10x plus 8. But remember, we were told that 3x minus 4 is a factor. So we can be able to use long division there so that we can be able to get the quadratic factor. So if we take 3x minus 4, we use long division at that point. We can say this is 3x cubed minus x squared minus 10x plus 8. We need to take here x squared, so that x squared times 3x will give us this, will be 3x cubed minus 4x squared. We subtract the two, we are going to get negative. No, it will be positive 3x squared. Then we shall pull minus 10 down, 10x down. We need to have here plus 3x no, we shall have x, not 3x. We shall have x here. X times 3x will give us 3x squared. X times 4, it will be minus 4x. Then again we subtract the 2. This will cancel out. We shall have negative 6x. Then we shall pull 8 down. 8 pull down. Which number would we multiply here? We shall say minus 2, so that it becomes minus 6x plus 8, and the answer becomes 0. So which means that f of x that we were having, which is 3x cubed minus x squared minus 10x plus 8, can be written as 3x minus 4 into x squared plus x minus 2. If you factorize this, it has to factorize to x plus 2, x minus 1, and therefore our f of x is now fully factorized as 3x minus 4 into x plus 2 and x minus 1. And that is the expression that is fully factorized, and that's what you are expected to have at this given point. Question number 6 is a question to do with equation of a circle.